There we go. Lovely. F5. Can we live? Please forgive me the meerkat. I just couldn't resist. And so I went round and around thinking, well, gee, what's at least a name for this sort of activity I want to get into? And to me, everything beginning with TK is such a buzz killer. I hate trying to invent names that begin with TK, so I played with that a little bit, and this is what I came up with. F5 hasn't worked yet. Let's see. So, whys and wherefores. In my file of interesting articles, I have a chapter from a book by Donald Norman, and the title of the chapter is Attractive Things Work Better. And it isn't just a cuteness factor. It's actually based on he goes into some depth of the psychology and brain chemistry and what have you, is that you feel better, you feel more comfortable using something that looks good, and so on. And so that's actually, I'd love to be Boost Tickle and TK, and I think 8.6 has so many goodies in it that someone was chatting with me. I think Ed Huntley was saying, well, we need to hire a marketing guy. I'm not it, but I'll throw the idea out there. And there's so much more you could add to TKCon. There's so many different tools for various aspects. And it's been around a long time and it needs a little love. So that's my attitude. It hasn't zoomed yet. So some of the things you could put in, one of the first things I did when I was just getting started with Tickle was TKCon came up, it was ugly, really ugly. The font was wrong, it was the wrong size. And I didn't know it. I just went into the code and found a little font setting and hacked it. So that's been my interaction with TKCon over the years. Is every time I find something that I just go and hack the code. Another thing that's happened to me recently is I have carried around a package of Unix tools to run on Windows. And I finally ran up something where the package wouldn't work, which was Server 2003. So I have no corn shell. So I want to do everything in TKCon. I think it'd be great to have some sort of shell mode in there. It's already got calculator mode. Shell mode where the redirection characters in the pipe and so on are broken out for you, so you don't have to put white space and so on. It just behaves a little more like you'd like a Unix command line to work. The domains here, as I'll talk about a little more, which is something I also hacked in, is where you start it up in a different directory. You get a different history file, you get a different color, you get a different screen placement, and so on. So if you're working on 4 or 5 different related components, you can keep them straight, keep the history straight, and so on. And whatever you think of. Only a couple more. Wow. This windowing system is really not happy. Excuse me? I have been. I noticed Avast was busy downloading its latest version, so that's nice. Am I on the next slide? No, I'm not. Okay, so the stuff that's on my list. We've got these great regular expression visualizers. Why not just have a toolbar, TKCon? There's the database tools, sockets. I work a lot with images, and I'm always just typing the code by hand to load an image and reduce it and view it and so on. So there's a lot of great stuff there. And the funnest thing of all, I think, you don't even need to touch TKCon. We can just, I'll probably just start out building an add-on file. Everything you wanted to do, you can insert the menu, you can add a toolbar, you can do whatever you want. I've never gotten Control-Z to work. Has anyone on Windows ever had Control-Z work in TKCon? Does anyone know what it is?
What's it supposed to do?
It's saving and buffering the command line. It has never worked. Control-G does work if you substitute.
Isn't Control-Z end of file?
Excuse me?
Control-Z on Windows. Control-Z on Windows.
Is end of file, right? Yeah, but I don't know why that. I haven't been able to explain why that doesn't work. So the funnest thing I would like to do is just add on this what I've called domains here, which is once again just separating out. So you can have multiple TKCon workstations on your machine and sort of get them the way you like, get the fonts, get the color, get the separate history most of all. And so that is my whip for TKCon. Anyone interested in playing, let me know. I'll be, see the wiki. Further news.
You have 2 or 3 minutes. Any questions? No questions? Okay, up next is Arjun, followed by Brian Griffin.
Okay, well, during my presentation I've already mentioned the things I would like to do with respect to distributed computing. The thing I like is I'm not sure how to what form it will take, but things I usually work with are programs which will do their job, having some input, they produce some output, and quite often I would like to have a whole series of computations running at the same time. Luckily at my place I have a cluster, a Linux cluster to do that. But preparing the jobs often takes quite some time, and things have to be done manually. So if I can automate that, like in the system I presented before, but in a more general way, that would make life a bit easier for me and for my colleagues. Most of the time, it's just getting the whole set of input files, putting it on a machine, a Linux machine, or perhaps PCs which are not in use at the moment. Run the program on that particular machine and get back the results. From there on, you can then analyze whatever you want to do with that. That's the sort of thing I would like to have in a really nice, generic way. I don't know what form it would take. One of the difficulties would be to distribute the input and get back all the output files. It was mentioned on the chat that Fossil could be a sort of file server. I think that I could indeed use Fossil to put all the input files in one place, distribute that file, unpack it, have the computations run on that machine, and then get everything back also via Fossil. That would be one way to solve the distribution problem I see. Another thing to work out is how to know which machines are available for this work. PCs would have to register themselves that they are available for such work. I know that Andreas has worked on things like COM in Triple. We've been talking about it a few years ago, I think, about how to make that sort of thing a bit more flexible or easier to use. That's the sort of thing I would like to work out in the coming month. I don't think, yeah.
Would it make any sense to use AWS for your storage? So you don't have to really truck the data between your server and the clients, or just keep it all up on AWS?
Yes, if that's possible. On the other hand, the result files will always be specific to your computation, so you have to deal with that somehow. For instance, via directory structure. But that doesn't take away the problem that the machines that are going to do the work have to be known. They have to either pick up the work themselves or be instructed to do that. So that's a problem which still has to be solved.
Right.
Yeah.
Bob's going to suggest I do a similar project. It would be useful to take, basically look at the different ways we solve those problems and see if there's something that we all could do to kind
Yes. Well, there are a lot of different ways to do that. Have a cluster, and of course you can then schedule all things, and the scheduling software will take care of distributing it. But if you have local PCs or Linux machines that normally just run on their own, they don't fit in that model. And it would be nice to use all these PCs and Linux machines, but they're just there because your colleagues are not.
Have you thought about using one of the frameworks such as, say, the ones you might say at home? Or that sort of thing?
I have, no.
I have a cycle launchers.
I know of them. I've never looked into how to do it.
What I've run, with our application, what I run into is restoring, several hundred megabytes of data, and it really doesn't help to interrupt it and stop it. It's kind of, it starts, it runs for hours, and then it uploads this huge file. So.
In the case of Monte Carlo calculations, so we see when you start, as well as the fact that Monte Carlo is independent.
Yeah, but I'm also talking about large analytical simulations that just have to run for a couple of hours and produce hundreds of megabytes. Yes, you could.
Indeed, Landers is still currently both mentioned the use of make.
Yes, I made a note of that. I think it's very nice way to have all kinds of computation started.
Given that your statement as sort of distributed computation is determined completely by the set of completion files that your sub-processes generate when they're finished, you can set rules up that say, I want to run this job, to create this kind of job, I expect this kind of job with a similar sort of name like we do with .org and .c file.
Yeah.
Then running the make file will tell you where you're at and guarantee to advance you monotonically towards the completion of all of the data that you want to write. And I overheard Steve talking the other day about a distributed one, slightly distributed one. Steve,
it's the set of computers you're talking about. You're talking about a set that's ever changing, or a set number of computers.
Okay.
Well, I mean, DistMake is an application that runs across a network.
Right.
You have a make daemon running on each computer, and a master daemon reads the make file and then apportions the jobs among the various servers, various computers. So
I knew the parallel version of make, but distributed I didn't know.
yeah, it's something
So that's
I would like to
interesting.
look into. Yeah.
Okay.
The thing about, if I can take another second, DistMake requires that every client computer share a file system space, and they recommend NFS, which carries all these problems that come with managing NFS. Fortunately, we now have in the typical world not only TCL VFS package, but the TCL Fuse package that allows you to see TCL virtual file systems by any application, including Make. So if I wanted to make a large-scale process-level parallel paradigm computing situation, I would set up DistMake using TCL Fuse and TCL virtual file systems to create a single shared network file system using something like Amazon Simple Storage Services as the storage backend. Or you could use a local computer as a storage backend. And I think that would scale very well for things that relied on controlling many processes with files as inputs and outputs.
Yeah. Okay. Well, certainly sounds interesting.
But there require any hardware upgrades, or can you use good PCs?
Well, I mean, Make has been used for many, many years on all sorts of different computers, and it scales well to large computers. It has command line options that allow you to set a maximum number of parallel jobs, also a maximum load average, so you don't accidentally bury any of your computers. DMake or DistMake?
DistCC.
DistCC, yeah. Same basic idea.
Okay, thank you.
Next is Brian Griffin, followed by Cliff.
This is somewhat related to the last one, I think. So,
This is about a tool I put together as part of our regression environment. Yesterday you saw our simulator model set. It's been in development for well over 10 years. Very complex tool. We have right now up to we have over 11,000 lockdown regression tests that we have to run before anyone can check any code changes in. And this is just a subset of the test. It's the minimum set in order to check anything in. Each test will run for a maximum of 5 minutes. If we let it go longer than that, if you do the math, 11,000 tests, 5 minutes, they get hung. That's over an hour. In the grid, where we have, so we have this big grid set up. There's, I don't know how many processors there are, but there's about 750 slots. Some processors, most of them take about 6 slots per machine. So they can run 6 jobs, concurrent jobs in the machine. It is Honkin file server with a really fat pipe to the grid. And a couple years ago, we had this problem where we're running these tests on there, and they're just taking forever. And it's the NFS just bottlenecked. Even though we had a fat pipe here, there was just so many file transfers going on. And part of the problem was that after you run all these tests, you have 11,000 tests. Now you have to figure out what passed and what failed. And there was, the only way to find out was to go walking through all 11,000 tests in the file system to find the ones that failed, because the log file would be a pass-fail file created. So another developer, wasn't me, worked on some wrapper programs, and he came up with a system of instead of, there's 2 parts to it. Instead of having to scan all the 11,000 tests to see which ones passed or failed, he had this script. There's an initial script. It's all written in Perl. Our whole regression system is written in Perl. But we have this test that would fire off all the tests onto the grid, submit the jobs. And this little run test wrapper script would, when it started running on the grid, it opens the socket back to this little server that's sitting there monitoring things. And it would just send one message. Test number 17 has started. And then it would close the socket. It would run the test. When the test finished, it opened the socket again, said test number 17 passed. Close the socket and go. The second piece was, and then this thing would create a log locally in the on the user's drive on their desktop. The second piece is the instead of having the tests running off of this filer across that fat pipe, we create caches. So there's a local cache on every machine in the grid that's updated nightly. And so that all the disk access was local to the machine. It would use the cache copy, run the test locally. If it passed, it just cleaned everything up, and on it went. If it failed, only the failed case, it would save all the files back over to the filer in the user space. There's some pre-processing that has to go on before the jobs are launched. For those tests that have been modified locally, it runs those off the filer and not the cache sets. Those few changes, by re-architecting it that way, sped the running regressions from multiple hours to like 20 minutes to run all 11,000 tests. It was shockingly fast. So these are all just shell-level scripts to set everything up, and I hate using shell-level scripts and to do things. So of course, I had to put a GUI on top of it. I'd run it live, but the internet's too slow and I can't run it locally. This is a little movie. And let's see if I can rewind this. Is it going to play for me now? Oh, it's not going to play. Okay, here we go. All right. So the first part of this, there's a little setup, and there's a configuration file where you just put in the information, which test you want to run. Let's see. This is where your tests are on the file, what platform you want to test. There's a test suite. In this case, I have a custom file name, but you could put in just the lockdowns, and it knows what tests those are. This is just a small, I have 22 tests in this case. So instead of editing a configuration file and then feeding that to the script, there's a little GUI on top of the configuration file. This is a big boon for a lot of our users, having that alone. So once you set it up, it also does a concurrent build of the software first. And there's all the results are presented. There's which tests are running, which tests have failed, tests that somehow got lost, tests that have passed, and so on. Once you, let's see if we scroll down. So you can set up the build, whether you want to build the software or not, and then just run the test. You start it. It submits the test to the grid. Now what the GUI is doing is just running the Perl scripts behind the scenes and monitoring the results coming back. And so that socket connection I talked about before, that little Perl server that's listening to the socket connections from the test turns around and passes those same messages to my GUI. And then I display the results. So there's the test running on the grid, and this is the order. And as each test, in this case, these are all failing tests. As each one responds back that it's done, it immediately shows up here instantly. The moment it finishes, the test shows up there on the list.
Is that part of the video or is that real?
This is a video. This is a video of a run I did earlier today.
I think people talk about the low battery one.
Oh, that one. All right. Yes. So as soon as the test comes back that has failed, you can double click on the test and actually see the transcripts of the results, which maybe will show in a minute. So I can select the failed list, I can go to the test. The other tests are still running. There's still 13, 11 tests running, 10 tests running. This tells you how many of the tests are running from the cache, how many are not in the cache that are local. At some point, I double click on a test, it shows up. It'll show you the log file from the test.
I have a question.
Sure.
It shows pass, 0, fail, 60%. What about the other 40%? What happened to those cases?
They're still running, so you don't have any results from it. Yeah, once they're all finished, it should come up to 100%. I've double-checked that a few times. The really interesting thing is the really cool work was all done in the Perl script and to speed up this whole regression system. But it was hard to use. I put this GUI on it, and like everybody comes to me and says, "What a great job you did, Brian." I just slap this GUI on it. Of course, I also get the bug reports. It didn't work right in this case, at HAN or whatever. Well, it wasn't mine, it was the script on it. It wasn't the Perl script messed up. So I still find that interesting that the base of the application is GUI that I put on. So all the real work is in those Perl scripts. Any questions?
Do you actually attach to the other
This is, yeah, there's the Perl script runs as a server, and it has it's listening to a socket connection when I bring up the GUI. That's the other thing, I can bring up the GUI and bring it down up again, and it knows how to find the server and connect back to it. So if this were to crash or something, it wouldn't stop the redemptions from running itself. And so there's, it actively connects to the server, and they start communicating. What's really cool is the test itself on the GUI. So it's, hello, I started, you can send a message and one done, communicates back. And it's really fast. It's fun to watch the pass message just whiz by. Makes you feel good. And the really neat thing is you can start diagnosing the problems with that test as soon as they fail. Start looking at it. And it dropped the NFS traffic to test there. Okay?
The more I think, the curiouser I get. What kept you from putting a progress bar in here?
I actually had especially right as you get a progress bar in mind.
Good question. I certainly put a progress bar in there, but this is it's using 8.4 with tile. It's switched to 8.5 yet, but I can change the theme here. It's interesting to walk around the offices and see the different themes that people have.
As soon as the machine's finished booting up, knowing that it's got a projector attached to it, what I'm showing is a plotting library and an application that I built around it. Mostly this was driven by the period of time when it turned out that you couldn't get DLT to compile with what was current on the WISH tickle development, and I needed graphs, so I started writing and realized that one of the things that drove DLT back in the early days was the need for vectors. If you wanted to do graphing, you needed vectors because the backward tickle was always a string. The conversions from integer to string to integer and string back again was just so horrifically slow that George had to invent the vector to keep something in a native format. Now we've got Ticklage. We don't need that so much. So I wanted to do something that built a graph on a canvas so that I had way more control over what I actually displayed when things finally finished up than I had with BLT, where my formats were pretty tightly constrained to the way that George wanted his graphs to look, which wasn't necessarily the way I wanted mine to look.
I noticed the window manager.
It's MPWM with a few tweaks.
I remember using FEWM on the last one.
Yeah, well, I finally tweaked it to do what I want. So, you know, the new ones don't do what I want. I don't want dancing clowns. And I was playing with GNOME at one point. I downloaded, and what's the Japanimation character? I ended up with that for my style. And there were just little girls in short skirts sitting on top of all of my windows, but they're all 10 years old. You get arrested for that?
Maybe you think he was yesterday.
Now you know why I use FPWM instead of GNOME. So this is the kinds of things that, it looks like normal graphs, log scale, regular scale. Put in support for either drawing to where things change or midpoint or only showing half the change. Because sometimes, especially the kinds of data that I'm working with, when you actually draw something that looks like lines, that's not right because we're looking at discontinuous data. It's on or it's off. I don't have 3 and then 3.2% off. It's all on or all off. Some of the things you get for free in these is being able to toggle things on and off. Being able to go in and zoom.
People there, people like to represent.
Yeah.
Yeah, you're not running 3.86, are you?
Actually, this is 8.6. That's why we've got our rotated. So you have double clicking will bring the label back on or off, or it can be moved around. Art histograms, either stacked or side by side, as George did. Or sideways, timeline, color bars. And again, I'm missing one.
Done on canvases?
Okay.
Done on canvases? Is it done on?
Oh yeah, it's all done on canvases. The first step is canvas dot whatever, then then initialize graph on this canvas.
Sure.
Someplace where it also does pie charts and area graphs, which for some reason or other are not showing up right now.
You have that magic button that makes all your. Oh wait, that's on a Mac.
Yeah. Actually, they do it on GNOME too, but then you have to have the little girl with the short skirt under all these windows.
You can get that on. I have no